students, today we are going to cover our lecture on Theory of Costs, Part 2nd B, Long Run Costs of Production. It is the reference to time period involved in the production process used in production analysis. There are two time references, short run production process and long run production processes. The short run refers to a period in which the supply of certain inputs like plant, building, machinery, etc. is fixed or is inelastic in nature. In short run, therefore, production of a commodity increased by increasing the use of only variable inputs like labor or raw material. Short run may be a matter of few weeks or few months in some industries and may extend to 3 or more years in other industries like electric and power industries. There are two types of processes which are carried in any production process in a firm. We term them as long run processes and short run processes. For long run production processes, it refers to a time period in which supply of all the inputs is elastic, but not enough to permit a change in technology. We cannot change the technology variable input in our production process when we refer to long run. In the long run, production of a commodity can be increased by employing more of both the variable and fixed inputs. Here we can change our machinery, our plant size, our raw materials. A variable input is one whose supply in the short run is elastic, like labor and raw material. It is one that changes with the change in output. A larger quantity can be used in short run of variable inputs. In long run, all inputs are variable in nature and they can be changed one after another, unlike short run. Now the long run cost curves. Long run is a period in which all the inputs become variable. There are certain key assumptions which we have to be taken care of during plotting our long run cost curves. In long run, supply of all the inputs, including those held constant in the short run, becomes elastic. Here we can change the plant size, we can change the supply of raw material, we can change the labor, we can change the capital, but in long run the technology is not the input which can be changed. Firms are in the position to expand the scale of their production by hiring a larger quantity of all inputs like both labor and capital. Now what is the long run cost curve? We call it as envelope or planning curve also. It shows the least per unit cost at which any output can be produced after the firm has had time to make all appropriate adjustments in its plant size. We already have discussed that in the long run, certain short run period production processes are included. So the long run cost curve are plotted when the firm has taken full time of its establishment. The long run cost output relations imply the relationship between the changing scale of firm and the total output, whereas the short run cost curve represents the relationship between the total output, maybe labor or capital. It can also be said that a long run time period is composed of a series of short run production decisions. Thus, a long run cost curve is composed of a series of short run cost curves. We can see and understand this concept by this illustration. We can illustrate the concept of long run cost curve by the following example. A firm's short run average total cost curve at a relatively low can be plotted graphically as follows. At a relatively low output level of Q1, in the short run, the firm might have short run average total cost curve SRATC1 as its short run average cost curve, having C1 minimum cost at quantity Q1 when the firm has only one plant. At a slightly higher output level in the short run, the firm might have short run average total cost curve SRATC2 as its short run average total cost curve with minimum average cost at C2 Q2 when a second plant is added. Further, at a still higher output level in the short run, the firm might have SRATC3 curve as its short run average total cost curve with minimum average total cost at C2 Q2 after addition of a further third plant in its original size. In the long run, the firm can pick any appropriate plant size. At each output level, the firm picks the plant that has the SRATC curve, the short run average total cost curve, with the lowest value. We can see in the graph SRATC1 curve, the first curve of the firm with C1 Q1 value. Similarly, a second short run average total cost curve when the plant has added Q2 quantity of output, C2 Q2 as its minimum average total cost. Then further, plant has increased its size and it moved further to C3 Q3 quantity size cost with short run average total cost curve 3. Further, the plant has increased its output level from Q1 to Q4 and it has C4 Q4 minimum average total cost with total average cost curve in short run as SRATC4. Further longevity in the time period of organization, the firm has a higher output level from Q1 to Q5 with minimum average total cost at C5 Q5 and the average total cost curve at this point is short run average total cost 5. So, the long run average total cost curve is made up of segments of short run average total cost curves. This is short run average total cost first, this is short run average total cost curve second, this is short run average total cost third for third time period, this is short run average total cost curve for fourth output level, and this is the short run average total cost curve for fifth output level. In many industries, the number of possible plant sizes is virtually unlimited. Then the long run average total cost curve is made up of points of tangency of the theoretically unlimited number of short run average total cost curves. To find out long run average total cost curve, we have to find out all the short run total cost curves in the long run and we have to point out the tangents of all these curves. Then the long run average total cost curve is smooth. We can see in this graph, we have a tangent from short run average total cost curve 1. Then we have another tangent at short run average total cost 2. We have our third tangent point at short run average total cost curve 3 when our output is Q3 level. We are having our tangent at SRATC 4 and at the last we have our tangent at quantity 5, the last limit of the output level from Q1 to Q5. We have SRATC curve 5. You can see that a line of graph is plotted from SRATC first to SRATC 5 with a lower slope from SRATC 1 and SRATC 2 with quantities Q1 and Q2 output level. Then we can see a constant slope of long run average total cost curve when we are having quantity level Q3. With further increase in the size of the organization, we are having an upward slope of long run average total cost curve at Q4 and Q5 level. The downward sloping section of the long run average total curve reflects economies of scale. Economies of scale As plant size increases, there are factors which lead to lower average cost of production. Labor specialization. Jobs can be subdivided and workers performing very specialized tasks can become very efficient at their jobs as they are performing the same job for a longer time duration. Second is managerial specialization. Management can also specialize in a larger firm in areas such as marketing, finance, personnel, and the last but not the least, equipments that is technologically efficient but only effectively utilized with a large volume of production can be used. After a long run production process, we have already used our equipment which have been produced a larger quantity of output for our organization. Similarly, we have diseconomies of scale. As plant size increases, there are factors which led to higher average cost of production. Expansion of management hierarchy level leads to problems of communication, coordination, and bureaucratic red tape, and the possibility that decisions will fail to mesh. The left hand doesn't seem to know what the right hand is doing is the case when the expansion is there of our organizational plant size. The result is reduced efficiency. In large facilities, workers may feel alienated and may shirk, not work as much as they should do in the long-term process. Then there arises requirement of additional supervision that adds to costs. As we have added a number of people at supervision level, we have to pay them, we have to give them salaries, we have to give them compensation. So ultimately, this will lead to the rising cost of the organization. The upward sloping section of the long run average total cost curve reflects this diseconomies of scale. Sometimes there is a segment of long run average total cost curve which is horizontal. In that case, the long run average total cost is constant and there are constant returns to scale. There are no changes in the cost whether it is related to specialization or there are no lack of coordination or expansion of or mismanagement of organization. Once we have the long run average total cost curve, we can determine the long run total cost. Remember that average total cost is equals to total cost per unit of output. So total cost is equals to average total cost multiplied by our output Q. From the long run total cost curve, we get the long run marginal cost either from the following two formulas. Marginal cost is equals to change in total cost divided by change in unit of output level, or marginal cost equals to DTC divided by DQ. We can denote it in both ways. As in the case of the short run marginal cost and average total cost, it is also true that for the long run curves that marginal costing is less than average total cost when average total cost is decreasing. Marginal costing is higher than average total cost when average total cost is increasing. And marginal cost is equals to average total cost of long run curve when average total cost is at its minimum level. Furthermore, when the firm has built the optimal scale of plant for producing a given level of output, long run marginal cost and short run marginal cost will be equal at that output. That is, the long run marginal costing and the short run marginal costing will intersect at that quantity level. Thus, that will be our marginal costing output level. We can also determine the long run total cost curve from the expansion path. The expansion path shows how the quantities of inputs change as output increases, but the prices of inputs remain fixed. We can see 3 isocosts at K1 L1, where our labor is L1 and our capital is K1. Our expansion path E1 is the point where our total cost curve has been cutted with the isocost line. Second, when our capital is increases from K1 to K2 and our labor is also changed from L1 to L2, we have a second point on our isocost line, that is E2. Furthermore, when our capital is increases from K1 to K3 and our labor is increased from L1 to L3, we have another point E3 which is tangent to the isocost line. If we connect all the 3 points E1, E2 and E3 from our place of origin, we can have this expansion path, and this will be our long run total cost curve. We can again explain it like this. Suppose that the price of labor is rupees 10. As we have already discussed that the price will remain fixed when we are plotting long run total cost curve. What we can change is amount of labor and the quantity. So, here in particular at point H1, our quantity level is 25. The cost is the price of labor times the amount of labor, or 10 multiplied by 25, that is 250. So, here when we are having our quantity 25, we will have a coordination point E1 with 50 to 50 on this long run total cost curve. Similarly, the long run total cost of output 100 is 10 into 37 when we are having our quantity from 25 to 37. So, at this level of quantity of 37 points, we will have 100 370 as another point on long run total cost curve as E2. In the same way, the long run total cost of output 150 is 10 into 45, 450. So, 150, 450 is a third point on our long run total cost curve with point E3. So, our long run total cost curve might look like this. We have 3 different quantities and we are having 3 different long run total cost points. For output 50, we will have long run total cost of 250. For increase in output from 50 to 100, we will have also an increase in long run total cost 250 to 370. At the third point, when our quantity further increases from 100 to 150, our long run total cost curve also increases from 250 to 450. So, this graph can be plotted as long run total cost curve with 3 points which are creating its expansion path. Often there are additional goals than costs that contribute to long term profit maximization. For example, a better image makes it possible to attract more productive employees and more customers so that our overall profit maximization can be done. Today, we have studied in this lecture the long run cost of production, the long run production process, how long run production process is different from short run production process, the long run production process composed of a series of short run production processes, and the calculation of long run marginal costing and the plotting of long run average total cost curves by the expansion path.